Good afternoon, students. And today we will be continuing with our lesson, that is, which we were doing motion. And students, till now, what we have covered is what is motion, then what is distance, what is displacement, what is the reference point, uniform, non-uniform motion, and we have also completed the uniform speed and the non-uniform speed. As I told you in class today, we will be progressing also with some of the numerical concept. And today, the first one, we will try to work out with the average speed, how to calculate the average speed. But before going into the calculation of the average speed, through the chat box, you give me the reply that how we can calculate the average speed. What is the formula for the average speed? Yes. What is the formula for the average speed? Anyone? Yes. Okay. Very good. Total distance traveled by the total time taken. Okay. So now let us do one question. Let us do one question. Just a moment. Okay. Yes. Now all of you, we will be writing this question and we will also work out with this. Let me do some initial settings of the page. Fine. Now, see students, what is the question? This is regarding the calculation of the average speed. Okay, so we will write the question first. Just a moment. We will write the question first. Question is, an object, you will also write along with me, an object travels 16 meter in 4 seconds and just a moment. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. Stop. I think, yes, my screen is clearly visible to all the students, what I have written. Please give me the remark through the chat box. Okay, fine. Fine. Yes, I got the feedback. Okay. Okay, continue. In 2 seconds, what is the average speed of the object? What is the average speed of the object? So I repeat the question. This is the question. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. what is the average speed of the object? Okay. Now, students, before going into the solution of this question, can anyone just can anyone, okay, through the I would like to unmute you. You quickly raise your hand. How we can proceed this? Which formula we will be applying over here, and how we can proceed with the solution of this numerical? Any idea? Okay. 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 Quickly raise your hand so that I will unmute you. Okay. Siddhant 9E has okay, Siddhant, you can unmute yourself. How we can proceed? Only just tell how we will be proceeding with the solution. Yes, Siddhant, I have unmuted you.
Yes, sir.
Yes, Siddhant, go ahead. How we will be proceeding with the solution of this?
Sir, by calculating average speed.
So how we will do the average speed? What is the formula for the average speed?
Total distance traveled by total time taken.
Very good. So here, students, yes, correct, Siddhant, you can mute yourself. Now see, students, what we are going to and how we are going to do. Now we will be doing the solution for this. Now we will be doing the solution for this. The solution of this numerical. Okay. See, first, students, we have to calculate total. First, we'll be calculating total distance traveled, and what is the total distance traveled? Total distance traveled is equals to 16 meter plus 16 meter is equals to, that becomes your 32 meter. Got it? So first we have to see, students, that what is the total distance which was traveled by the particle, and the total distance traveled by the particle is definitely 16 meter and another 16 meter, that is equals to 32 meter. And now we will see what is the total time taken. Total time taken is equals to 4 seconds. Initially, for the first 16 meter, the object was taking 4 seconds, and for another 16 meter, just a moment. For another 16 meter, it is taking 2 seconds. So that makes your total 6 seconds, isn't it? So students, you have got that what is the total distance traveled and what is the total time taken. And now we know the formula for the average speed. Now we know average speed average speed is equals to total distance traveled, by by total time taken. Okay, total distance traveled by total time taken. And that makes it to that makes it to 32 by 6 is equals to, it will be coming to 5.33. What it will be the unit, students? What will be the unit for the average speed? What will be the unit for the average speed, student? Okay, very good, very good. Yes, correct. It is meter per second. Very good. Meter per second. Correct? Meter per second. So this is the solution for this question, and this is the answer. That is once again the question. And I hope all of you have written this also, that an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? And for the solution of this is, first we have to calculate the total distance traveled, and then we have to calculate the total time taken. So total distance, definitely it is 16 plus 16 meter, that is equals to your 32 meter, and time is 6 seconds. So the average speed, total distance divided by total time, that is 32 divided by 6, that makes your 5.33. Is it clear to all? Is it clear to you all? Okay, fine. Okay, okay, yes. Yes, I got the feedback. Okay. Fine. Okay. Now, students, after this, we are coming to the next portion of the chapter or the lesson, that is the concept of velocity. Okay. Today now, we will be doing with the concept of velocity. So now, students, we will be doing the concept of velocity. That is a speed with the direction. Students, as you all know, when we have discussed about the speed, speed was the scalar, or we will be saying speed is a scalar or a vector quantity, students. Speed is a scalar or vector quantity. It is a scalar because it has only magnitude and no direction associated with it. So speed definitely is a scalar quantity. And now the speed with the direction, that means definitely a vector quantity. And what it is, the concept of velocity. And for this, students, definitely we know that the rate of the motion of the body gives us the speed, wherein we have no information about the direction of the motion of the body. The rate of motion of the body will be more comprehensive if we will specify the direction of motion along with its speed. So what is, and the special term, the quantity that specifies both rate of motion and the direction of the rate of the motion is definitely called velocity. So what is a velocity? It is a distance traveled by the body in unit time in a given direction. Okay, so this is what we call velocity. Now, student, as we have said that the velocity is the speed of the body in a particular direction. So what will be the mathematical representation for this? The mathematical representation for the velocity is same like that of speed, only the direction is being specified. So what is velocity? All of you, the definition you all have written. Now the mathematical deduction you can do over with the here, that you will be writing velocity is equals to velocity. Yes, velocity is equals to distance travel in given direction divided by the time taken divided. Let me enlarge it. Yes. Yes. Velocity is equals to the distance traveled in a given direction divided by the time taken. Divided by the time taken. Or velocity is equals to displacement by time. That is a distance traveled in a given direction. That will be definitely the distance which is covered between the initial and the final position, and that is called the displacement. And so velocity, and this arrow indicate the direction, is equals to s by t. You have to write this also, where v is the velocity, s is the displacement of the body in time t. Okay, in time t. Is it clear to all? Now, students, again here, the same thing which we have discussed regarding the scalar and the vector quantity. Velocity is a scalar or a vector quantity, students? Velocity will be a scalar or a vector quantity. What do you think regarding velocity? Okay, very good. It is a vector quantity. Definitely correct. Correct. Yes. So you will write this also. Velocity is a vector quantity. Velocity is a vector quantity since it has both magnitude and direction. Velocity is a vector quantity since it has both magnitude and direction. Okay. And remember, student, the SI unit, the unit of velocity is same as that of the speed. So this also you will mention. The SI unit of velocity is meter per second. SI unit of velocity is meter per second. It is represented in the same way as we represented in the speed. Only difference is that the speed, they don't have a direction. That means it is a scalar, but the velocity is a vector quantity. Now, students, after this, we'll be coming to the topic uniform velocity or the constant velocity. Okay. Now, when a body is moving along a straight line covering equal distance in equal interval of time, the velocity of the body is said to be uniform or constant. That means, with an example, we can have a more idea for this. When a train travels over a straight horizontal track covering 60 kilometers in every hour, the train is said to be in the uniform velocity of 60 kilometers per hour. That means it is covering equal distance in equal interval of time. That means every hour it is covering 60 kilometers. So here the velocity is uniform. Okay. Okay, so till this, students, is it clear to all of you, the concept of uniform velocity with the example? Is it clear to all? Okay, fine. Now, students, we'll be coming to the next topic, that is the variable velocity or the non-uniform velocity. So what do you mean by a variable velocity? Definitely, when a body covers unequal distances in a particular direction in equal interval of time, so that will be called a variable velocity or the non-uniform velocity. But always we should remember, student, there are certain conditions on the basis of which the velocity of the body is variable. And what are that? The velocity of the body can be changed by either changing the speed or by changing the direction, or if we will change both the speed and the direction. So in all the three cases, we will be saying the body will be facing, or the body is under the non-uniform, the body is under the non-uniform velocity. So either the speed changes or the direction changes, or both the speed and the direction changes. So that becomes our variable velocity. Okay, so till this we have done the variable velocity. Now we will be coming to the next topic, again very important one. That is a, like student, we have studied about the average speed. So now we will definitely study about the average velocity. So when a body is moving along a straight line at a variable speed, definitely its velocity is also variable. In that case, we express the rate of motion in terms of average velocity. So when the velocity of the body is changing at a uniform rate over a period of time, then average velocity of the body is definitely the arithmetic mean of the initial and the final velocity. So how we can deduce this? So here what we will do, we will take out the arithmetic mean by adding the initial and the final velocity divided by the 2, where UAV is the average velocity. Just let me use the, yes, where this UAV is the average velocity, U is the initial, V is the final, and this is the formula for getting the average velocity. Student, average speed, as we said, total distance by the time, but average velocity we will take out by taking the arithmetic mean of the initial and the final velocity. So student, this is all about today's class. So in today's class, we have studied that how we can calculate the average speed. Then we studied what is velocity, uniform and the non-uniform velocity. And then finally, we concluded with the average velocity, where we are taking the arithmetic mean of the initial and the final velocity. Student, today's assignment definitely will be, you all will prepare with these terms and the concept which we have gone in today's class. Okay. So thank you students for today's class.